Okay class, today we are learning about the fuse. A fuse is a safety device that protects electrical circuits from too much current. First, let's see how it is made. A fuse has a thin wire or strip of metal, called the fuse element. This wire is specially chosen because it melts quickly if too much current flows. The fuse is always connected in series with the live wire, so if it melts, the whole circuit is disconnected. Now, what makes a good fuse material? It should have a low melting point, so it melts easily, high conductivity so current can pass normally, and it should not oxidize or wear out quickly. There are different types of fuses too. For example, cartridge fuses, rewirable or KitKat fuses, HRC fuses, and plug-type fuses. Each type is used for different purposes, like in homes, industries, or machines. When we talk about a fuse, we also discuss its ratings. A fuse has a current rating, which is the maximum current it can safely carry, a voltage rating, and also a breaking capacity, which tells us how much fault current it can handle before breaking safely. Now, the advantages of fuses are that they are simple, cheap, and effective. But the disadvantage is, once a fuse blows, you cannot use it again, you have to replace it. That's why in modern systems, circuit breakers are often preferred. Finally, where do we use fuses? You'll find them everywhere, at home, in vehicles, in electronic gadgets, and in industries to make sure our appliances and wiring stay safe. So remember, when studying fuses, focus on the definition, construction, working, properties, types, ratings, advantages, disadvantages, and applications. A fuse is a small safety device used in electrical circuits. Think of it like a guard that protects your home appliances and wiring. It is made of a thin wire or metal strip. When too much current, more than safe limit, flows through the circuit, the wire inside the fuse heats up and melts. Once it melts, the circuit breaks, electricity stops flowing. This prevents damage to the devices and avoids fire. Backhand index pointing right. Remember, a fuse is always connected in series with the live wire, so that it can stop the current immediately when something goes wrong. Functions of a fuse. You must know two things. 1. Protection during short circuit. If a short circuit happens in the wiring, a very large current flows through the wires and the fuse. The fuse wire, fusing element, melts and cuts off the current, protecting the appliances and the wiring. If the fuse does not work, the wire may get very hot, melt the insulation, and even cause a fire. 2. Protection during overload. If too many appliances are connected to the same circuit, more current flows than the wires are designed to carry. This can make the wires hot and damage both the wires and the appliances. The fuse melts and stops the extra current, keeping the circuit safe. Working principle of fuse. A fuse works on the principle of heating effect of electric current. When current flows through a conductor, the conductor offers some resistance. Because of this resistance, heat is produced in the conductor. Now, if the current is more than the safe limit, the heat produced becomes very large. The fuse wire, which is made of a material having low melting point, melts quickly. This breaks the circuit and protects the electrical equipment from damage. Now let's talk about the materials used for fuse wire. Fuse wire is made from metals that can melt easily when too much current flows through them. Some common examples are tin, lead, zinc, copper, silver, and even alloys like a mixture of 63% tin and 37% lead. Why do we use these materials? Because they have a low melting point. That means if excess current passes, the wire melts quickly, the circuit breaks, and our devices stay safe. Now, different materials are chosen depending on how much current the fuse needs to handle. For small currents, up to 3 amperes, we usually use lead. Lead melts at about 327 degrees Celsius, so it breaks the circuit quickly when the current goes beyond the limit. For currents between 3 and 15 amperes, we use a lead tin alloy. This alloy melts even earlier, around 239.5 degrees Celsius, which makes it very suitable. For currents above 15 amperes, we use tinned copper. Copper itself has a high melting point, about 1093 degrees Celsius, but when coated with tin, it becomes more reliable and safe for higher currents. And finally, in high rupturing capacity fuses, or HRC fuses, we use silver. Silver melts at about 961.8 degrees Celsius, and because it is highly conductive, it works very well for handling large fault currents safely. So remember, lead for small currents, lead tin alloy for medium, tin copper for higher currents, and silver for special heavy-duty fuses like HRC. Now let's learn how to select the right fuse wire for a circuit. First, we need to look at the maximum current rating of the circuit. The fuse must allow the normal current to flow without melting, and it should only melt when the current goes above the safe limit. Second, we think about the smallest wire in the circuit. The fuse must protect even the thinnest wire. If we choose a fuse with a higher rating than that wire can handle, the wire may burn before the fuse melts, and that is dangerous. Third, we consider the type of load. For steady loads, like lights and fans, we choose a fuse close to the normal current value. But for fluctuating loads, like motors, we choose a fuse with a slightly higher rating, because motors take extra current at the start. Now, let's talk about the points to keep in mind while choosing the fuse wire itself. Current rating: the wire should melt only when the current goes above the safe limit, not during normal flow. Material: fuse wires are usually made from tin, lead, copper, or a tin-lead alloy because these metals have low melting points. Thickness: a thin wire melts easily and is used for small currents, while a thicker wire can carry more current before melting. So, the thickness must match the circuit's current rating. Safety factor: always keep the fuse rating slightly above the normal current. For example, if a circuit normally carries 5 amps, we select a fuse of about 6 amps. There are 3 important definitions you must know. KeyCap 1 rated current, or current rating of fusing element. This is the maximum current that the fuse wire can carry safely for a long time without melting. Backhand index pointing right example: if the rated current is 5A, the fuse can handle 5A continuously without breaking. KeyCap 2 minimum fusing current. This is the smallest current at which the fuse wire will melt. Even if that current flows only for a very short time, the fuse will blow. KeyCap 3 fusing factor. This is the ratio of minimum fusing current to rated current of the fuse wire. Its value is always greater than 1, because the fuse must carry the rated current safely and should only melt when the current goes a little higher. Properties of a good fusing element. When we choose a material for the fuse wire, it should have some important properties. Let's see them one by one. KeyCap 1: it should not get oxidized. If the material reacts with air and forms oxide, it will become weak and may not work properly. KeyCap 2: it should not be brittle. The wire should not break easily when handled. A brittle fuse wire will snap even before it is used. KeyCap 3: it should be homogeneous. The material should be uniform throughout, without impurities. Otherwise, some parts may melt faster than others. KeyCap 4: it should resist deterioration. The fuse material should not get damaged or weaken with time due to oxidation or heat. KeyCap 5: it should be cheap. Since fuses are replaced after every fault, the material should be low in cost. Types of fuses, based on construction. There are mainly 2 types of fuses as per construction. KeyCap 1 rewirable fuse. In this type, the fuse carrier contains a replaceable fuse wire. When the fuse blows, we don't replace the whole unit, only the fuse wire is changed. There are some advantages like: they are cheap and easy to replace. Very simple in construction. There are some disadvantages, like not reliable for high currents. They can be unsafe if the wrong thickness, gauge, of wire is used. Applications, mostly found in domestic wiring in older installations. Second is non-rewirable fuse. In this type, the fuse element cannot be replaced separately. Once it blows, the entire unit must be changed. Examples: cartridge fuse, HRC fuse, blade fuse, dropout fuse. There are some advantages like: much safer and more reliable. Standardized ratings prevent misuse. There are some disadvantages like more expensive compared to rewirable types. They have some applications like commonly used in electrical appliances, automobiles, industries, and substations. As per the screen, this is basic symbol used in connection diagram. Construction of round-type fuse, rewirable fuse. A rewirable fuse mainly has three parts: fuse body, fuse element, and fuse carrier. Let's understand each. Keycap 1 fuse body. It has two parts, the base and the cover, or top. It is made of porcelain or bakelite. These materials are strong and heat resistant. The base is fixed on a wooden board with screws. It holds the fuse element and has two terminals for connecting the fuse wire. The base can be removed easily whenever the fuse wire needs replacement. Keycap 2 fuse element, fuse wire. This is a thin wire or strip made of low melting point metals like tin, lead, zinc, copper, or silver. It is placed between the two terminals on the base. When excess current flows, this wire melts and breaks the circuit. One terminal is always connected to live wire, which is drawback during replacement of fuse wire. Keycap 3 fuse carrier, cover. Also made of porcelain or bakelite. Has small holes that allow air to enter and gases, formed during melting, to escape. This helps the fuse wire burn out safely. Keycap 4 metal contacts, end caps or ferrules. Made of copper, brass, or tinned brass. They give mechanical support and ensure a good electrical connection. Now, let's talk about the advantages and disadvantages of the round-type fuse. Advantages. The round-type fuse is a rewirable fuse, so its cost is low compared to non-rewirable types. It does not need regular maintenance. If the fuse blows, anyone can replace the fuse element just by removing the cover. Replacing the fuse wire is quick and easy, so it saves time. Disadvantages. Because the fuse is small in size, it is sometimes difficult to remove the fuse element. The first conducting terminal is always live, which makes it risky and difficult to replace the fuse wire safely. When the fuse blows, it may produce high pressure and arcing, which can damage the fuse unit. KitKat type rewirable fuse. Range: 5A to 3000A, 220V to 440V. The KitKat fuse is one of the most common rewirable fuses. Let's understand how it is built and how it works. It mainly has two parts: fuse element carrier, cover. Base. The base is fixed permanently on a wooden board with screws. Both the base and the cover are made of porcelain, which is a strong insulating material. The fuse element, wire, is connected between the two contacts of the carrier. When the fuse wire melts, we don't have to change the whole unit. We only replace the fuse wire in the carrier, which makes it rewirable. How it works. The base has two fixed contacts. One contact is connected to the main supply. The other contact goes to the load, the appliance or circuit we want to protect. The cover, carrier, is removable. The fuse element is attached to this cover. This design makes it safe. Even if the base is live, we can remove the carrier to replace the fuse element without directly touching the live parts. Advantages and disadvantages of KitKat fuse. There are some advantages. It is a rewirable fuse. This means only the fuse wire needs to be replaced when it blows, so the cost is very low. It needs no maintenance. Once installed, it works without regular servicing. It is easy to replace. Anyone can safely remove the cover with a holder and change the fuse wire. The replacement is quick and takes very little time. There are some disadvantages. The breaking capacity, ability to safely interrupt high fault current, is limited. When a fault occurs, the electric arc takes longer to extinguish, which may be unsafe. There is a lack of discrimination. This means it cannot always correctly identify and isolate the faulty part of the circuit. Sometimes, the main fuse may blow even for a small local fault. Non-rewirable type fuse. Let's talk about the non-rewirable fuse. In this type, once the fuse blows, you cannot replace only the fuse wire. Instead, the entire fuse unit must be replaced. Because of this, it is a bit expensive compared to rewirable fuses. These are widely used in motors and distribution systems, where higher safety and reliability are required. The body is generally made of ceramic, glass, or brass, while the fuse element is made of silver, which has a melting point of about 961.8 degrees Celsius. Types of non-rewirable fuses. There are two main types. HRC, high rupturing capacity, fuse. Cartridge fuse. HRC fuse. Range, 2A to 1000A, at or above 440 volts. It has a heat-resistant body made of glass or ceramic in a cylindrical shape. The fuse element is silver, fixed between two brass end caps. Inside, the fuse is filled with quartz powder, plaster of Paris, or chalk powder. This powder absorbs the heat and helps to quench the arc when the fuse blows. Working of HRC fuse. Under normal current, the silver fuse element carries current safely, no overheating. When current increases, the element temperature rises close to its melting point. When excessive current, fault, flows, the fuse element melts, the powder absorbs the arc, and the circuit is broken safely. Why silver is used? Silver has low resistance, so it carries normal current without much heating. It also provides consistent and reliable melting characteristics. Use of HRC fuse. Mainly used in industries for the protection of heavy machines like high HP motors. It has a high breaking capacity, meaning it can safely interrupt large fault currents. Though it has lower capacity than circuit breakers, it is cheaper and reliable for many applications. Let's now discuss the advantages and disadvantages of the HRC fuse in a very simple way. Advantages of HRC fuse. The HRC fuse can work well with both low and high fault currents, which makes it a very safe type of fuse. It can clearly distinguish between a real fault and a normal condition in the circuit, so it gives reliable protection. These fuses do not lose their quality or performance over time. Because of the quartz powder inside, they operate very quickly when a fault occurs. They always work effectively during faults, ensuring the safety of equipment. Disadvantages of HRC fuse. It is a non-rewirable fuse, so once it blows, you cannot just change the wire. The entire fuse unit must be replaced. The cost is higher, mainly because silver is used as the fuse element, and silver is expensive. Let's now talk about the cartridge non-rewirable fuse in a very simple and easy way. Cartridge non-rewirable fuse. The cartridge fuse is almost similar to the HRC fuse, but remember this, it is not suitable for very high horsepower motors, unlike HRC fuses. Its current range is from 0A to 63A and it can work at or above 440 volts. It has an insulating cylindrical body made of glass, ceramic, or porcelain. On both sides, it has metal end caps, usually brass, which connect to the supply and load wires. Inside the body, there is a fuse element made of lead-tin alloy, which has a low melting point. This fuse element is surrounded by powder, quartz, plaster of Paris, or chalk powder. The powder helps in quenching the arc and maintaining the temperature when the fuse blows. Under normal conditions, the element carries currents safely without overheating. Types of cartridge fuses. Axial type, shaped like a small cylinder with wire leads on both ends. Knife type, has knife blade contacts, used in higher current applications. Ribbon type, uses a thin ribbon of metal as the fuse element. D-type, available in small ratings, 100 mA to 10A, used in domestic wiring and small appliances. Let's discuss about advantages and disadvantages of cartridge-type fuse. There are some advantages like: it is suitable for both high and low temperature protection. Very easy to replace, the whole fuse unit can be changed without shutting down the entire system. It requires no maintenance. It has a long life because of its reliable construction. Since the fuse is a complete unit, it is quick and simple to replace. There are some disadvantages. It is a non-rewirable fuse, which means you cannot just change the fuse wire. The entire unit must be replaced, making it costlier than rewirable types, though cheaper compared to HRC fuses. After every fault, the whole fuse unit has to be replaced, not just the wire. As per the given motor data and our calculation, the rated current comes out to be about 1 ampere. The fusing current, which is 1.6 times the rated value, is around 1.6 amperes. So, for safe operation, we should select a fuse that is slightly above 1.6 A. This ensures protection without unnecessary tripping. As per the given motor data and our calculation, the rated current comes out to be about 1 ampere. A fuse works on the thermal and electrical properties of the fuse wire. The rated value is around 1.6 amperes. It heats up and melts. So, for safe operation, we should select on the principle of switching and electromagnetism. This ensures protection without unnecessary tripping. Reusability. Fuse can be used only once. Let's conclude our discussion on fuses in electrical systems. You have to replace it. A fuse is the simplest and most widely used protective device in electrical circuits. After tripping, you just reset it. Its main function is to protect electrical equipment and wiring from overcurrent and short-circuit faults by melting the fuse element and disconnecting the circuit. Fault. Fuses are classified into two main types. On-off switch also. Rewirable, function, fuse, inexpensive and reusable, both detection and interruption itself. Non-rewirable fuse, a circuit breaker and more reliable, though costlier. Detection is done by its relay HRC fuse and the cartridge breaking capacity. HRC fuses are mainly used in industries where high fault currents are common, circuits, while cartridge and D-type fuses are generally applied in domestic and low-power systems, suitable for heavy-duty systems. Although modern circuit breakers offer advanced protection, fuses remain widely used because they are simple, fast-acting, reliable, and economical. Circuit breaker is a little slower, continues to be a fundamental and effective protective device in electrical engineering. Mode of operation. Fuse is completely